wabarakatuh, and we meet again in lecture 5, and this is PMM 1533, Strength of Materials 1. We are going to continue with our CO1 topics, which is analyze stress and strain problems in structural members under axial loading. This is the CO and LO for this subject. And again, for this for today's lecture, we are going to calculate on the deformation of stress and strain of structure members due to axial loading. If you still remember, in our previous lecture, there's a factor of safety that we need to consider in our design, and the value of n need to be equals or more than 1 to ensure safety. And the formula for factor of safety due to stress design is that sigma d divided by sigma yield equals to sigma yield divided by the value of factor of safety. Now let us continue with our example. In lecture 4, we have learned on how to calculate the value of delta, which is elongation due to axial loading, but that one is known as statically determinate, which means that we can solve the problems using static equation or through free body diagram. But then there's another case which is known as statically indeterminate. This is because we cannot solve the problem itself only by using the equation from static or from free body diagram, and therefore we need to apply superposition method. How to apply this superposition method? Now let's look at this example. Let's read the question together. Determine the reactions at point A and B for steel bar and loading as shown in the figure, assuming a closed fit at both supports before the loads are applied. Okay. So from the figure itself, this is the figure by taking out the supports at end B. From there, we need to split a free body diagram. This one, structures elongate due to axial forces plus with elongation due to redundant load. From there, we know that the equation for delta equals to delta L, which is delta due to axial loading plus delta due to redundant loads equals to 0. So this is equation number 1. Yeah. Why it is equals to 0? Because the support at end A, there's no elongation there. It stays at the end of support of end B. Later on, we'll see another types of example. So the first step is that by using this free body diagram, we need to find the value of each P or forces at each section due to the existing of the axial loading and the changes in section. Why do we need to find this value of P or forces here? Because we know that the formula for delta is equals to PL over AE, and therefore we need to find the value of forces for each section. So if we look at this figure here, we know that the section who exists is 4. Number 1, this is section 1, and then section 2, because there's the changes in sizes here, so this is section 3. After that, we have a external forces here, therefore this one section 4. From there, draw free body diagram for each section. After that, you'll get the value of P1 which is equals to 0, P2 equals to 600 kilonewton, P3 equals to 600 kilonewton, and P4 equals to 900 kilonewton. From there, to make your life easier and to avoid any mistakes, you can either jot it or write it like this in a table form by section 1 until section 4, and substitute all the value in this table, starting from P1, P2, P3, P4. Same goes to length, area, and also Young modulus. From there, substitute into the formula, and finally you will get this value. The value of E modulus Young is not given to you, and therefore it is written as E there. So this is delta L. Now let's move on to delta R, which is a deformation due to a redundant load. So from this figure, you need to cut into two sections because of the difference in dimension. This one section 1 and this is section 2. From the free body diagram there, you'll get the value of P1 equals to RB, coming from the reaction force at support point B, and P2 equals to RB as well. Now let's put it in this table form, and after that, once you get all the value in the section, for each section, just substitute into this formula, and finally you get delta L equals to this. After that, substitute the value for delta L and delta R. This one represents for delta R equals to 0. From there, you'll get the value of reaction force at point B, which is equals to 577 kilonewton. And since the question asks you to find the value at the support A, and therefore you need to open up the support at point A and draw the whole free body diagram there. So from this free body diagram, you need to summarize the total forces in y directions equals to 0. You'll get the value of reaction force at point A, which is equals to 323 kilonewton. And altogether, you'll get the value of RA and RB. Okay. Now, in statically indeterminate case, there's two types of problem exist, which is just now due to axial loading, and this case is due to thermal stress or due to heat. So how to solve this problem? If you still remember in our previous lecture, which is lecture 4, delta T due to thermal stress equals to alpha delta T capital times L. This one, delta or deformation due to stress. However, since there's a support here, and therefore this one is considered as redundant load. Therefore, the formula will be delta equals to delta T plus delta P equals to 0. I think let's look at this example to make it more clear. Let's read the question together. The A36 steel bar shown below is constrained to just fit between two fixed supports when T1 equals to 30 degrees C. If the temperature is raised to T2 equals to 60 degrees C, determine the average normal thermal stress developed in the bar. Alpha is given to you, Young modulus is also given to you. So the first step to do is to draw a free body diagram. Yeah. And also to apply this formula. Delta equals to this formula, delta equals to delta T plus delta F equals to 0. So delta T due to thermal load, and this one thermal or change in temperature, plus deformation due to external load. So from here, delta T, for delta T here, you can calculate it. You can straight away calculate because all the information is given to you. And for delta F, okay. No, from this equation, sorry, a little bit mistake here. Okay, yeah, you from this formula you can rearrange you can rearrange it back so that you'll get this formula, F equals to alpha delta T capital AE. And since you have all the information, all the data here, just substitute all the information and you'll get the value of F equals to 7.2 kilonewton. And if you still remember, the question asked you to find the value of stress there. Therefore, just substitute into stress formula, which is stress equals to P over A or F over A. F, taking the value of F that you have calculated, this one, divide by area. So you'll get the value of stress equals to 72 megapascal. So that would be all for lecture 5. See you again in the next lecture. Thank you and bye-bye.